We were on CDK and cycline. Now we are going to discuss which are the different in different phases of cell cycle, which are different cycline and CDK are present. That is very important topic because as I told, these are the most favorite topic of CSIR or GATE. So phases of cell cycle, phases of cell cycle. Please mute yourself. Phases of cell cycle, and then which are the cycline that are present in which phase, cycline, and then CDK. So firstly, G1 phase. In G1 phase, you will find out that cyclin D is active. Remember that always the concentration or the amount of cyclin will fluctuate. It will just form or degrade according to the type of phase, type of the phase of the cell cycle. But CDK always present in the same concentration. It will not going to fluctuate. It is always present in the cell. So CDK 4 and 6, they are present in the G1 phase of the cell cycle. Then G1 to S phase, cyclin E will be there. Cyclin E will be there and CDK2. Then S phase, within S phase, there will be cyclin A and CDK2.
CDK1.
CDK2. Then G2 to M, there will be cyclin B and CDK1. So you can just learn this particular thing like DEAB in which particular manner you want to learn it or remember it. Just do it because this is important. So in G1 there is D cyclin and CDK4 or 6. G1 to S, E CDK2, S phase cyclin A, CDK2, and G2 to M, cyclin B and CDK1. So these are the different phases. We are here we are discussing about the higher eukaryote. So remember that within higher eukaryote, these type of CDK and cyclin will be present. Clear to all?
Yes, ma'am.
Just remember that one thing, in yeast, single CDK is present. In yeast, only single CDK is present. Which particular CDK? CDK, CDC 28 and CDC 28 or CDC 2. In yeast, there is only single CDK. So how it is possible that this single CDK catalyzes different phases of the cell cycle? What do you think? How it is possible? Only single CDK is there, but then also it is showing the it is showing the cell division. How it is possible?
Because yeast is unicellular.
So how it is correlated with unicellular or multicellular? Is there any correlation? No one? See, as I told you earlier also, that CDK concentration will always be same within the cell, but cyclin will vary. So CDK is present single, but there are different cyclin partners at each phase of the cell cycle. Cyclin will vary, but CDK remains the same. So if cyclin will vary, then there will be different formation of CDK cyclin
Combination.
yes. So there will be different cell cycle different phases of cell cycle will go on. Is that clear?
Yes, ma'am.
To all? Any confusion till now? Any doubt, any query to anyone? No one? Should I proceed?
Yes, ma'am.
Okay. Now, have you heard about V1 kinase? That is another regulatory protein present in the cell. That is V1 kinase. Have you heard? No one?
No, ma'am.
Okay. So it is inhibitory kinase. Inhibitory kinase. Kinase, you know? Kinase is what? Kinase is what? Kinase is an enzyme that do
Enzyme.
phosphorylation. Yes. So this V1 kinase is inhibitory kinase. If there is mutation in V1 kinase, see V means something small. So if there is mutation in V1 kinase, so which type of cell you will get? A smaller size cell you will get. Cell, very smaller cell, small size cell you will get. This is also very important question of CSIR. They just asked in the C section that if there is a mutation in V1 kinase, then which type of cell you will get? Larger cells, smaller cells, like this. So a small size cell you will get. And why it is so, we will just see later on. So firstly, I will show you the role of V1 kinase. Any doubt? See, this is very, very important topic. Number of time there was question from this only V1 kinase. So this is your cyclin B, and this is your CDK, that is CDK1. Cyclin B and CDK1. So of which particular phase we are talking? Which particular phase is here? Which particular?
G2M.
S2M.
G22M, cyclin B and CDK1. So here there is, this is particular location for threonine. You know threonine? 14th residue is of threonine.
Amino acid.
Yes. And 15th residue is of tyrosine. So what is happening?
Aromatic amino acid.
So what is happening here? Actually, this threonine and tyrosine, they are inhibitory phosphate group. Here there is an attachment of phosphate at 14 threonine and 15 tyrosine. And these two phosphate group, they are inhibitory type. And this whole complex is in inactive form. Because as I told, this threonine and tyrosine, they are in inhibitory phosphate group. They are showing inhibitory phosphate group. So this whole complex is inactive, and this complex is known as mitosis promoting factor. Mitosis promoting factor, MPF. This is the short form, or maturation promoting factor. So this, how this inhibitory phosphate come on threonine 14th and tyrosine 15th? This V1 kinase add inhibitory phosphate to this residues. Am I clear?
Yes.
Till now? Any doubt?
No.
Okay.
No.
So this is about V1 kinase. Later on, we will discuss that how this inhibitory phosphate will remove. But here, this is another type of regulatory protein. That's why I just discussed here. So I'm just moving to another regulatory protein, that is activatory kinase. Anyone? Activatory kinase. In same picture, I will just change the color. And activatory kinase, they are known as CAK. CAK, that's CDK activatory kinase. These are this is your inhibitory phosphate at threonine 14 and 15, and this is CDK1 cyclin B. This is MPF, that is inactive form. What is the role of this CDK activatory kinase? They are formed with CDK7 and cyclin H. Cyclin H will be there. CDK7 and cyclin H, they will form the activatory kinase. What are their role? Their role is to add phosphate at threonine 161. Is that clear?
Yes, ma'am.
Okay. Now, this is another activatory, this is another regulatory protein, that is activatory kinase, that consists of CDK2 and cyclin H. Their role is to add the phosphate at threonine 161 position. Now, another regulatory protein is activatory phosphate. Not activatory kinase, now here phosphatase. Activatory phosphatase. Again, I'm just changing the color. Activatory phosphatase. That is CDC25A. CDC25A, that is activatory phosphatase. What is the role of phosphatase? They just remove the phosphate group. So, this CDC25A phosphatase, what it will do, it will remove the inhibitory phosphate from threonine 14 and 15. It will remove the phosphate group. And what we will have only the CDK1 and cyclin B and threonine 161, that is having phosphate attachment. That is what? Now, this is mitosis promoting factor and this is active in state. Clear? Now it is in active form. Am I clear? Is there any doubt to anyone?
Can you repeat, ma'am?
Yes. Obviously, I can repeat. See, V1 kinase, we have seen that in V1 kinase, there will be some inhibitory phosphate will come and bind here. The role of this V1 kinase to attach or add phosphate to threonine 14 and 15. So that will form the MPF inactive, mitosis promoting factor inactive. Now here comes in this scenario, your activatory kinase will come, that consists of CDK7 and cyclin H. What is their role? This kinase will add phosphate at threonine 161 position. Now, this happens. Till now, any doubt?
No, ma'am.
It is not touching
No.
inhibitory phosphate because now the role of CDC25A will come because it is activatory phosphatase. As the name suggests, it is a type of phosphatase that will activate any particular factor. So this CDC25A, it is removing the phosphate from threonine 14 and tyrosine 15 because as we already discussed earlier that these two phosphatase, they are making the mitosis promoting factor inactive. So if this CDC25A, that is a phosphatase, if it will remove the phosphate from this particular location, then this mitosis promoting factor will be active. Clear?
Yeah, understood, ma'am.
Okay. Any doubt to anyone?
No,
But
ma'am.
the mitotic promoting factor cannot directly act the CDC25A, na? The order should be CAK.
Yes.
Afterwards, we have to remove the CDC25A.
Yes. Order will be likewise the order that we discussed, same manner. They will come one by one. Firstly, V1 kinase, then CAK, then CDC25A.
Okay, ma'am.
Okay. Any other doubt?
This is of eukaryotic or prokaryotic?
Eukaryote. We are discussing about eukaryote. See, eukaryotic cell cycle regulation is very complicated, and in various examination you will got the question from these side, because it is a little bit complicated or confusing. The student get confused from which particular location phosphate will be removed, or from which particular residue phosphate will attach. That's why. So should I proceed?
Yes, ma'am.
Okay. Now we are going to discuss another type of regulatory protein that are known as inhibitory protein. As the name suggests, they will inhibit something. So what they will inhibit, we will see. Inhibitory protein. So there are two types. At the time of cancer discussion, we will discuss them. The role is very important of these inhibitory protein. INK4 and CIP, they are known as CYP or KIP. CYP or KIP family. So they are cyclin inhibitory protein or kinase inhibitory protein. Clear? Cyclin inhibitory protein or kinase inhibitory protein. INK4, they are inhibitory kinase 4. Inhibitory kinase 4. Their role is to, they are basically, which are the INK4, P16, P18, P19. Okay, you guys tell me why we are just using term PP, always P. What is this P? You have heard about
For protein.
P53. That is guardian of cell genome. What is this P and what is this number?
Is it related to the removal of addition of phosphate group at the number of residue amino acid?
Okay. Any other answer? See, P is basically for protein. As I told, these are inhibitory protein. P is for protein, and the number that you are finding here, they are actually the molecular weight of the protein. P16, P18, P19. They inhibit which particular CDK? They inhibit CDK4 or 6. They will arrest the cell cycle in G1 phase. As we have seen that CDK4 play a very vital role in G1 phase. So if this P16, P18, P19 will be there, they inhibit the CDK4 and 6, then cell cycle get arrested at G1 phase of the cell cycle. Clear? Any doubt?
Yeah, ma'am.
Okay. Now CYP and KIP, that is cyclin inhibitory protein or kinase inhibitor protein. They are P21, P21 and P27. What are their role? They inhibit the CDK2. They inhibit the CDK2. Means cell cycle will arrest at S phase of the cell cycle. Which particular phase will get arrested? S phase. Any doubt?
No, ma'am.
So I'm just thinking to bind up here because it's already 8:52. I have another class. So I'm just stopping it here. I hope you guys have gained something from this class.
Yes, ma'am.
Yes, ma'am.
Okay. So thank you so much for joining and listening. Bye-bye. Take care.